From centimeters, area expansivity is the increase in area per unit area per degree rising temperature.
Area expansivity, beta, equals to A2 minus A1, divided by A1 times theta, or delta T, temperature change.
A rectangular piece of iron measuring 4 centimeters by 3 centimeters at 20 degrees centigrade is heated until its temperature increases by 100 degrees centigrade. The linear expansivity of iron is 1.2 times 10 raised to power minus 5 per Kelvin. Now we all know that linear expansivity is different from area expansivity. Linear expansivity is in one direction. Area expansivity is length times breadth. Area expansivity is given as 2 linear expansivity. Area expansivity beta is given as 2 linear expansivity. Calculate the area. Now we know that area is length times breadth, which is 4 times 3, 12 centimeters square. So that's the area. Since we also know that beta is equals to 2 alpha, beta is given as 2 alpha. Alpha is 1.2 times 10 raised to power minus 5 per Kelvin. When you multiply this, you get 2.4 times 10 raised to power minus 5. When you multiply 2 by this, remember that this 2 is only going to multiply 1.2, right? Then times 10 raised to power minus 5. So that's your beta. Remember that beta is equal to A2 minus A1 all over A1 theta.
Area expansivity, beta, equals to A2 minus A1, divided by A1 times theta, or delta T, temperature change.
Beta is equals to A2 minus A1. A2 is final area minus initial area all over initial area times the change in temperature. So since the question says you look for change in area, you are automatically looking for A2 minus A1. So A2 minus A1 is equals to beta times A1 theta. A2 minus A1 equals to beta A1 theta. So that means that we are just looking for beta times A1 times theta. Beta is 2.4 times 10 raised to power minus 5 per Kelvin times A1, which is 12 centimeters square, and change in temperature is 100. Why are we using 100? Even though the question says that it was initially 20 degree and it increased by, there is a difference between increase by and increase to. If you say increases by, we are saying that the temperature increase is 100. If they said increase to 100, that's when you do 100 minus 20. If they say it increased from 20 to 100, then you would do 100 minus 20. But this one says it increases by 100. It was 20 before and it increased by 100. So 100 is the rise in temperature. But if it said 2, so the English will determine how you're going to do your workings. If it said that it increased from 20 to 100, then you would do 100 minus 20. But of course, it did not say it increased from 20 to 100. It said it was 20 before and it increased by 100. That means by 100 means now it is now 120. So that means that 20 take away 120 minus 20 is 100. So it increases by. This is the degree rise in temperature, 100 degrees centigrade. Rearranging this, you have 2.4 times 12 times 10 raised to power minus 5 times 10 raised to power minus 2. That's 28.8 times 10 raised to power minus 5 times 10 raised to power 2. And law of indices, 10 raised to power minus 5, when you have the same base and this is times, it becomes plus 5 plus 2. And because 10 raised to power minus 3, minus 5 plus 2 is minus 3. So 28.8 times 10 raised to power minus 3. So minus 3 means moving backward 3 times. Times 10 raised to power minus 3. 1, 2, 3. So this is the new position of the point. So you're going to get 0.0288. That's 0. So after all the whole calculations, we found out that our answer is 0.0288. Okay, so change in area is 0.0288 centimeters, all squared. So of course from there you can get the final area. Final area A2 is equals to A1 plus change in area. That's 12 plus, of course we say change in area is 0.0288 centimeters. The answer is 12.0288 centimeters. So the most important thing is for you to master the formulas: alpha, beta, gamma. Expansivity is equals to L2 minus L1 all over L1 theta. Theta is change in temperature. Beta is A2, area expansivity, A2 minus A1 all over A1 theta. Theta is change in temperature. Gamma, volume expansivity is V2 minus V1 all over V1 theta, change in temperature. Is the same thing.
Area expansivity, beta, equals to A2 minus A1, divided by A1 times theta, or delta T, temperature change.